So this is only meant to be like sometimes we refer to it as a cliff notes. Basically, it's just meant there to be a summary, general information, but then to use it properly, you need to go a little bit further just to make sure that you know all the ins and outs. Okay, so we already talked about the multinomial logit. So that means there's no ordering structure there, and that causes some issues with how we actually structure the marginal effects and some of the other stuff. When it comes to the order, our life's a little bit easier because that helps us create some type of way of keeping track of where that particular choice falls within all the choices. Okay, so we basically use this whenever we have a natural ordering system, something that we typically all, or not always all, but most would agree on. So in this case, we have one option. So one option is to treat it as continuous and estimate by OLS. I will tell you that sometimes we do this. Okay? You'll see this in some cases just because it is a simplified version, just like when we use the LPM, right? At the averages, we're probably going to do okay. And in some ways, it might give us enough information that we can see whether we should, continue to search for different controls, maybe better ways of modeling the dependent variable. There's always something out there that might be helpful, but remember that any type of models like this, they do take time to estimate, especially as the number of covariates get larger, as the data set expands. We're using different methods that are numerical in approach and not sort of what we refer to as the calculus in terms of OLS approach. So that's one way. We can treat it as continuous and just hope for the best. The other one is to think of it as a latent variable. We see the choice, but the actual measure of the choice might be, or what the choice represents might be unobserved. And it might be continuous. It might be good to assume that. So in that way, we assume that an unobserved latent variable y star and use an ordered logit or Probit to define whether we've reached a point to where once we go over that point, we've made the new choice. We've jumped over to that boundary to get to the next choice. Okay, so in that case, we can make this a latent variable model to where we can formulate it just like we would typically OLS. But then because we can't view that continuous variable, we're going to make some assumptions on how it's viewed. So within a certain cut, if you want to call it that way, we basically say the observed outcome rule is this. So we view 1 if y star is less than some tau 1, or you could say some cut point. Then once we view that and we're over that tau 1 or that cut point, somewhere between that cut point and the next cut point, we view 2. And we can think about this every time we add our choices. We're going to try to figure out where we are within the set. So in this case, the very first and last choice, or they're not in between these two cut points, but depending on how many k we have. So basically, if we have three choices, we're going to have, in this case, 2 cut points. We just need to know where tau 1 is, and we need to know where tau 2 is. Okay, after we know that, basically that's all we need to do. Now when it comes to actually estimating these thresholds, I'm not going to go into that too much, but the program is estimating these cut points for you. Okay, and everything is going to be sort of in some ways important in terms of these unknown thresholds that you're actually estimating. Okay, so that's the way we're thinking about this ordered outcome. So to give you an example, if we're thinking about, we have 3 choices that we observe. We see 1, 2, and 3. Whatever you want to consider them, if you want to consider them some stages, I just said 1 was low, medium, and high. Not really giving what that's in reference to. But from that, we might assume that we have a y star that's continuous. Once that continuous measure reaches 10 or is less than 10, we're going to say we observe y equal to 1. Once we cross that threshold, then the y star that we see until a point, say 25, we would observe y2. So we're just trying to make some reference to some continuous value that gives us why that choice was observed. And then if we have a y3, anything above 25 would then give us the y is equal to 3. In that case, we're basically saying that that variable y star represents the underlying continuous traits, say satisfaction, risk, whatever we're thinking about. And the observed y is more like groups within that continuous outcome. Basically, when we're looking at the traits, we're looking at the categories, and we're trying to help group the information together. Okay, so thresholds like 10 and 25 are estimated, and we determine how the values of y star map into the levels of y. Like I said, I'm being very sort of vague on this. It's more about just knowing how the sort of model's working, but trying to stay away a little bit from the math. So we can set up a cumulative probability distribution or expression that basically looks at the probability of y being less than or equal to k, in this case one of our choices, given x is equal to some function of the cut point minus the x beta in this case. Okay, and for the ordered logit, remember there's always a link sort of back to the previous things in terms of, because now we can order them, we can always sort of characterize it into, in this case, a very simple logit once we know those cut points that are going to be estimated. So we take it from something very complex into something very simple once those cut points are estimated. Okay, so this is why we show the logit and the probit first, because those are kind of important in understanding how we're going to do the calculations for this. So if we wanted to put out the whole full conditional distribution, we could write it out as basically the probability of observing a specific outcome. Let's say if I was looking at y equal to 1, then basically, and by the way, k, I'm thinking about it as being 0 ordered from 0 to k. Then basically the probability of y equal to 1 given x is going to be the probability, or the function of the cut point at 1 minus x prime beta. Minus, in this case, it's the cut point before, but because we're at 1, I guess this is kind of odd. I should probably start it at 1 and not 0. It's a strange way I've ordered this. So let me rephrase how I'm doing this. So I'm going to put it still k is equal to 0 to k, large k. So the probability of y equal to 1 given x is the function, in this case, of tau of k, so that's going to be 1. So remember, there's going to be a cut point for 0. Anything below that cut point for 0 is going to be, we're going to see a view as 0. Anything after that cut point, we're going to view a 1. So we need to know what that cut point of 1 is minus x prime beta. In this case, the other cut point would be, in this case, tau of 0 minus x prime beta. Once we have this, these are the CDF functions. And because these taus are estimated, or threshold, or cut points, whatever, and then the x prime betas are linear index, basically we can formulate our expanded probability outcomes. Okay? So this is where, once we know these cut points, then basically these become constants, right? Within this function. That's all it is. Once we estimate these, we use these as the assumptions in terms of what's estimated for these cut points. Then we can make the calculation for the probabilities. Okay, so that's where this problem comes in, is that we have a additional thing that we need to figure out, that threshold. If we're going from one choice to the next choice, then when we're reviewing that next choice, we need to know where the threshold ends there, and then continued on. In the very last, however many tau we have, basically the final category uses this particular functional form, so it's equal to 1. So the probabilities are going to be bounded between 0 and 1, and we know that the sum is going to be equal to 1. Each of the probability captures a chance of the latent variable falls between the thresholds. So basically, thinking about it as this is what we're kind of concerned with, of where the probability is going to lie. Okay? We just need to know where to look within this, where these thresholds are, so that we know what the probability is capturing of that continuous latent variable. Okay? I know, like I said, I know this sounds a little strange because I'm trying to be very general about it, but this can be helpful in terms of the intuition. So now these are not, this is just simulated data, thinking about it, just trying to visualize it in some way. So the cumulative curves for the ordered Logit or Probit, I think in this particular example I used Logit, yeah. Basically what we're getting is each of the lines is showing the cumulative probability of y less than some value. In this case, I chose 4 possible values. So in this case, I'm looking at, this is looking at the cumulative probability for the choice being at 0 versus at 1 versus at 3. Sorry, this is 0, 1, 2, and then this is 3. Okay? Basically, we're looking at the change in the probability is sort of that vertical distance. It's that jump moving from one to the next. Okay? So in an ordered Probit, if we have 4 categories, this is sort of how we would picture it in our heads. Okay? Because I'm not used to doing this in some of the research I'm doing, I'm not sure if they go for more visual versus more a table approach in terms of how they actually show the results. I was actually thinking that if I should have asked this before Steve left, and basically asked him, because he's worked with some of these, what's the best approach for when you have many choices? My guess is for few choices, they would go with a table for the best way to, show your outcomes, versus with a lot of choices, you're most likely going to want to go some type of visual approach. Okay, so like I said, this is just supposed to be a visual representation of that. When it comes to interpretation, each of these thresholds define the boundary between going from one category to the next, or in this case, going from, in your case, going up in terms of your ordered categories. Okay, the coefficients betas show how the covariates shift the distribution with respect to the continuous or the latent variable. So a change in x is going to moves the probability mass across those categories. The marginal effects, again, just like with the multinomial, it is a little bit more complex on our calculation, but think about it as if the program is defining these cut points, and we know what the linear prediction is of the x's, then it's about just calculating this and putting it into which one we chose. Did we choose Logit or did we choose Probit? So it looks more complicated, but it's mainly the fact that we just need to know the cut point, that linear prediction, and then we're back into our world of just, pushing it through the logistic or the normal. Okay? So don't let that scare you. It's basically just let the program sort of go through and estimate the cut points, and then a lot of the steps remain the same. The good thing also is that basically because we can pull this out, then we can use at least the coefficients to sort of understand how it's going to be signed a little bit. There is a little bit of an issue because there is this position. So in that case, if this becomes negative and negative, then it might not exactly work out perfectly. But again, it's one of those things that I need to look at because even though I know how to run these models and to use them sometimes, it's been a while since I've actually gone through and thought about whether you can sign the coefficients or not. I need to think about that myself. So we estimate the impact of the predictors and the likelihood of falling into each of the categories, and not just one binary split. Okay, so before we were looking, it's very similar to the Logit or the Probit in the sense that knowing which one we're falling into. We're trying to predict that. Now we're trying to do the same thing, but we're trying to do it across which bin we're going to fall into now. But the good thing is now that it's ordered, it gives us some structure. Before, we didn't know how the things were related for the most part. Now, because of the ordered structure, it simplifies our lives a little bit. Okay? So when we think about the probability curves, again, this is simulated data. It's not meant to be used for everything, but in an ordered response, the probability of each specific outcome is the difference between the two cumulative probabilities. So basically, being in category 1 versus in category K versus being in category K minus 1 minus the linear predictors. Okay? Each curve shows the probability of falling into that specific category, and basically the peaks of the curves shift depending on the cut points. And each curve integrates to the probability mass of that category. That's just some jargon that we have. But the key here is that basically before, when we were only focused on which function we were using, which distribution we cared about, and when we were only caring about the calculating the linear prediction, now we just need one more bit of information, in this case, those estimated cut points. Once we have that, then we fall into something that's, for the most part, easily calculable, that we can calculate. Okay? So I wanted to try to give an example from, again, from one of the data sets, just to again, like tonight, when I fix all the code and stuff like that, it's one of those things I'll give you the code as well to let you sort of practice and go through this. And it's one of the Wooldridge examples in terms of ordered logits. Okay? It's going to be focused on the POC 1998 data set, basically looking at pensions from the Wooldridge package again. And then basically we're only looking at a subset. I was trying to remember what the subset meant in this case. I think it's still the same number. I think it's only 1 year of data, which is the same as the data set, but I think they removed some observations for some reason. I would need to know why. I forgot why it's a subset. But the outcome in this case is mostly it should be considered in some ways a way of agreeing upon basically if I have individual choice, how should it affect my allocation of assets? So if I'm able to tell whoever's holding my pension fund that I want my assets allocated in this particular way. And in this case, they're looking at just 3 types of outcomes. Mostly bonds they put as numeric as 0. Mixed mixed is numeric 50%, and then mostly stocks 100%. Okay, most people would order these in a very similar way in terms of some form of risk, I guess you would call it. You could think about it in a different way as well. And then we have our determinants, which are, do I have the choice or not to make my choice in terms of allocations? Okay, age, education, and then we have a lot of characteristics: female, black, married, financial conditions, and then also wealth in 1989, and I'm forgetting what this last one was, the PRT. But it's not our primary variable of interest. In this case, it's the choice. Okay, the response probability is going to be defined in terms of a Probit. So under choice 1, we're looking at whatever the cut point 1 is minus our linear prediction. In terms of y equal to 1, then we're going to see that it's going to be this outcome versus the first outcome in terms of this is what we mean by it's the distance between those choices. So it's going to be the difference between where I'm at now in that outcome versus the previous. In terms of T2, because basically in some ways we can just simplify this by 1 minus the cut point 2 minus the linear prediction. So C1 and C2 are estimated cut points, or when we run the model. There's like I said, there's a formula for doing this, but I'm kind of leaving that away for now. In this case, so however many choice you have, you're going to have n minus 1 cut points, if that helps out in terms of where you're going to, how many cut points you're supposed to expect. Okay, and this is roughly how the model is set up. When we estimate the model, remember I told you that it's possible that I just am lazy and I decide to do an OLS. I can. Basically, I just treat the dependent variable as continuous, or and I don't have to treat it as continuous. I can just run the model. In this case, I could run an OLS and I get a particular outcome in terms of each of the characteristics along with choice. So in this very simple model, what it's telling me is that if I have choice, then it's going to basically increase by 1 unit, or basically switching from 0 to 1. It's going to increase my percentage, I guess, in terms of my choices by 12%, if I remember right. In terms of the order Logit, remember there's no comparison across. Okay? It's not the fact that this is 0.37 and this is 12 and there's no way of doing this. It's just that we need that extra step. Once we do the extra step, then we can make the comparison. Okay? And when I did I was trying to do the cut points to show you what they were because it wasn't coming out of my table. They kind of got switched over to here. In our case, our cut points between 0 to 50 or basically our first cut point is negative 3.087. In terms of our second cut point, it's negative 2.054. We only need those really for when we're going to do the next set of calculations. Did I do it? Okay, let me show this and then I'll jump back, to the other one. I should have switched these around. So in terms of the order Probit, in terms of the values or how we're comparing the choices, basically we can see it as our probability of, remember what this is. Y is equal to 0. Remember, if you go back to what we were looking at before, this is what we're actually calculating, the cut point minus that linear prediction. Okay? And that's the change in the probability of being within that category for, in this case, I'm just using the, what was I using? It would be the average marginal, if I remember right. In terms of y equal to 50, being in that next bin, basically it's going to reduce the probability with respect to choice. Basically giving me choice is going to reduce the probability of being in that bin. So the highest reduction is going to be in terms of the first bin, of whenever I have choice. The probability of being in the last bin, when I go from 0 to 1, it's going to increase it by 14%. Now, these are just those probabilities, but how do I actually go about comparing it to the OLS outcome? Well, basically, it's about looking at that expected outcome when choice is 1 versus when choice is 0 for that model. And what that happens is basically the value is the CDF in this case is under choice 1 is going to be 65.57. In terms of choice, when I don't have the choice is 0, it's going to be 53.011. So think about this as the same way as when we did that discrete outcome. Remember, it's the difference between have it and don't have it in terms of the logit. So when we do that in terms of the expectation, and we take the difference between the two, we find that the outcome actually equals 12.55. Now remember, the OLS outcome was 12.04. So the difference between the two models in terms of, how much more benefit do I actually get from having choice is very similar. There's not much difference here, right? So that's why I'm saying it's always might be good just to test it out in terms of running these models in OLS and then doing a quick comparison. In terms of the proportion of correct predictions by predicted outcomes, we could do the same thing as we did before, but now we can sort of look at what's the proportion that I was correctly predicting the person was in bin 0. Why did I flip those? I have to check and make sure this is ordered the right way because I put 0, 150. Usually we put 0, 50, and 100, so I gotta check that that's right. But basically, these would be what's the proportion correctly predicted. So how well did my model do in predicting whether their probability of being in that bin versus actually being in that bin? How well did I do? Okay, so once I have that, I have very similar ways of looking at how well did my model actually go about predicting this. Okay, and this is where I needed to go back one slide because the way I do those calculations is basically the same, very similar to what we had before in terms of the order Probit. We have our McFadden, we have our classification accuracy. This is just a weighted outcome from that prediction table that I had before versus how many people were in each category. And I could do that weighted outcome of this. And then I also have a way of looking at the test statistic for what we call the likelihood ratio test. So these are all ways of looking at how my model performed, and they're very similar across all these different models. Okay. And then from the proportional odds, there's a few assumptions that we go in here. Again, I've kind of glossed over this. And this is what I meant by finding and knowing more about the model before you're actually trying to put it into your work. Is basically we need to make some assumptions about how the assumed covariates have the same effect across thresholds. Basically, we're thinking about the effect from going from low to medium equals medium to high. That's how big of an assumption is that? It can be pretty big, right? Incorrect ordering. So what if for some reason I don't order bonds versus being a mix versus only stocks? What if I ordered it differently for some reason? I have to assume that everybody's going to order it the same way. So there is a possibility that I could cause issues with because I think an order goes one way, but you think differently. That messes up how you interpret all these models. We also, again, have omitted variable bias that I've sort of skipped over in the sense of just trying to keep it simple. And then we also have this linearity in index. Basically assumes linear effects across, or linear effect of covariates on the latent variables. Okay, we're assuming that our covariates are having a linear effect across that unobserved outcome. that unobserved continuous effect. So these are all assumptions that we have within these models. And I'll tell you that sometimes we relax these, and there are ways of relaxing them to allow for more complexities. We always, actually, in every model that we've done so far, there are ways of relaxing certain assumptions. And then going about trying to, those assumptions, when we relax them, allow us to be, in some ways, a little bit more realistic, but it also has those complications that we have to adjust for. Okay? I'm sorry I went through this fast, but the reason why I kind of did that is because I'm not sure if it's a good way of doing this, but I've put most of everything into the code so that I can then try to present it when you're looking at tonight, going through each, how the code is sort of aligned. And you can see how we go about all the calculations and then how we go about the performance, okay? So that's why it's going to be mostly kind of you tonight sort of looking at those different sets of code to see, you know, how it aligns with this. Okay. Time. The last that we've done prior to this is basically looking at interactions and binary regressors. So remember that we've said that this adds a complication to it, but at the same time, it's just going about the calculation and then feeding it through to the rest of and to the function itself, and then doing the calculation. So in case of something like when we were looking at the spam, we were thinking about a binary variable. So basically, is there multiple recipients within in the chain of the email? Okay. In that case, when we're looking at the coefficient, it represents that log odds of spam equal to 1 when multiple is equal to 1 versus when it's equal to 0. So it's not changing overall how we're considering it, but it's just like what we did with the OLS. We can't, once we start interacting and doing things like that, we can't separate these things out, right? You can't change one without changing the other. Okay, so that's why we have to be just making sure that we take into account that we don't focus on just the coefficient itself, but we also have to have the interaction. So in this case, we would basically look at the marginal effect, depends on the value of the other variables. But it's still thinking about it as whatever changes we're making or how we're doing that change, that it's going to be fed into our either logistic or into the normal, right? It's being fed into the function itself. So in the interactions, basically thinking about multiple versus the log number of characters. The effect of the log differs depending on whether the email is sent to multiple recipients or not. Okay, so it's basically saying that, you know, we're going to have one effect for one that's not sent to other recipients and versus when it is. Okay? And in that case, we can't basically interpret the coefficients separately in the sense of this portion on the linear. But when it comes to the derivative itself, we're still focused on the number of characters, right? So have to keep that in mind, that basically this is only feeding into the parentheses with the x beta. It's not feeding into the rest of it. The reason I'm trying to be clear with this, because remember at the very beginning of these calculations when we're doing marginal effects, remember it's always that coefficient times our calculations, right? So that means that even though we're doing the interaction, this doesn't get fed into the outside. It's only being really affected on the inside of the function. So basically we just need to compute this for multiple equal to 0 versus 1, and then compare how the slope's different. So it's just basically keeping track a little bit more when we have those interactions. Okay? To give you an idea, so if we looked at the predicted probabilities for the spam model, again, I'm going to provide the code, don't worry about And then we can basically look at the varying model in terms of the number of characters and thinking about what happens where we have 0 multiple. So basically it only comes to me, no one else. This is how the probability is changing as the number of characters are changing. Basically, it's negative, so basically it's falling across in terms of probability of being spam. In terms of the number of characters, if I was going, sorry, this is going up, so yeah, and then that's going down. In terms of where it had multiple recipients, same thing, just at the same points. But you can see that when I started out, I was at 2%, 2.5% versus 14%. That fall is a lot more drastic in terms of these predicted probabilities versus these. But this is, in some ways, still telling in terms of it is falling across. It's just that the fall is, not as dramatic as when we do not have multiple recipients. We could also, graph it out if we wanted to in terms of the entire set. It's just as we get more and more complicated models, sometimes graphs do help us sort of align and how to see it visually. It can be helpful in that way. This is the same information, just graphed out across all the possible outcomes for the number of characters. Okay? And, you in this graph, you can see that fall, whenever there's no multiple, basically I'm the only recipient, is a lot more drastic because we're starting from a higher portion versus the when we have multiple recipients. And we could also do the same thing for in a binary variable such as female and pension data. We could go about it doing it the exact same way. And we could also think about it in terms of interactions in the ordered Probit world. Okay, these things are all in some ways linked. It's just that the theory is sort of adjusted for multiple outcomes versus single outcomes. Basically, we can model it across all the different outcomes and think about the interaction between female and, say, wealth. What was your wealth in 1989? So whether the effect of wealth on the asset allocation depends on gender is a way of looking at it. In this case, the interpretation focused on the marginal changes in the predicted probability. So the effect of wealth, if I'm looking at that, it's the coefficient on wealth and this interaction times female. Or sorry, that shouldn't have been interaction. That should have been wealth 89 times female. Sorry. This is the coefficient, not the interaction. Okay, so when I take the derivative, but that is going to be inside the function, remember? So it's going to be the tau, whatever tau we're at, minus x beta. This is where this is coming in. So for both cases, like I said, graphical tools are kind of helpful here, or discrete changes are the most helpful. So thinking about turning a switch off and on. That's exactly what we're sort of doing with the earlier example, where we're thinking about turning that switch off and on. So when I have no multiple recipients and when I have multiple recipients, we're sort of switching it on, and then we see the entire drop. It's not going to be like it was before, where it's just a parallel shift. It's going to be, we should see a most times similar outcome, but it's going to be more of a shift, but we're going to see differences across the different discrete outcomes, in this case of number of characters. In this case, it would be across different levels of wealth. So we should see a dramatic shift, female versus non-female. Okay? And we can see it here in terms of, these are the multiple values I've chosen for wealth. This is what we have in terms of whether female or not. And then we have this basically a bunch of numbers, and you're trying to read them, you probably get confused very quickly. This is what I meant by the graphical side of it. So this is one way of looking at it, and I could probably try to read all these off and figure out what's going on, but it might be better just to see it as a visual across male and female. Now what I'm seeing here is basically, I do see similar patterns across, but there are shifts in the predicted probabilities of across the values of wealth, right? I do see, that allocation of 1, but there's a difference between the two. I probably could have overlapped them to make it a little bit more apparent. Similar for a 0 and versus, we don't get much movement in the mixed. It's mostly happening at the edges in terms of the 0 and 1. Okay? So I know that, I'm sorry I went through that fast. I was just trying to make sure I finished. So that basically whenever we go through and when you try to do the code tonight, you do have some idea of why you're going to be doing some of this. Okay? If you do it, I guess I should say. But if it's helpful to you, I would say kind of go through the code to see if this type of modeling structure might be more helpful to you. Okay? But again, these are just the basic general start to an area of research that can be daunting in some ways. So just keep that in mind as well. Yeah, this is the ordered. This one is just binary. That's why there's not additional line. But also because our choice variable that we have here is we're looking across multiple recipients. Now, if I actually got a count of the multiple recipients, say that I chose to group them. No additional recipients, 1 to 10 versus more. Then I would have 3 categorical outcomes. Then I could possibly have an additional line. That's where it comes in. So right now it's not the ordered or the multinomial in this case. We're only looking at differences in predicted probabilities across a variable that has only 2 categories. That's why there's only 2 there. But that's why I try to show these, because basically you can see that as you get more and more complicated the question, the tables become something that's telling, but it's hard to see visually when it comes to doing a presentation. You might see this in a paper, but if I'm doing a presentation, I'm not showing this because I'm going to have somebody squinting to figure out what all the numbers are. Is it going up, down? Then I'm having to compare the outcome of 0 versus 50 versus 100. The dimensions become a little bit too chaotic. That's where the visual representation helps out in terms of take it down to something that somebody could look at and say, oh, there's a difference. I can see that, male and female are different. I can see that my choices are different. That's where it becomes a little bit easier to see visually when you go to the next page. Okay? And that's why I was wanting to do the code, is because I wanted to show you that, okay, you can do the tables like we've been trying, but then you can actually start to do a little bit more advanced in trying to see how could I model it a little differently. Like tonight, could you take this and instead of doing female, do it across, what's there? Let me just look real quick. What if you decided to, instead of doing it across male and female, you decided to do it for, say, all the education categories? Think about how you might be able to visually represent something like that to see how it's varied across. Maybe there's some type of link between choice and your education level. And then we could actually look at those varied outcomes, and that would be maybe interesting. But I'm guessing here, because this isn't a paper I've read in the last 10 years or so. So remembering all the little details, I'd need to go back and look specifically at the paper to make sure I remember all the specific things that were being analyzed. And specifically about, what the variables are specifically, the intuition, what they mean, sort of. Just because you say choice, there's a way the author was sort of thinking about what the choice is actually doing to how it affects your dependent variable. Yeah. But it's just going from something like this that's a little bit hard to understand to something graphically usually is kind of helpful. Okay. Okay, so like I said, I'm going to throw the code in there. Try to, if you want to play around with it, to see how you, about understanding it as well as trying to go through and maybe even modify it. You could then ask some questions tomorrow. And that, I'm not sure if that's exactly the best way to do it. It's just when I was trying to go through and I was trying to go through the slides, it kept dawning. I kept just thinking in my head that if I keep putting more and more equations, that you're going to fall out of your chair. That's what I was worried about. So I figured I'd try to give the best story I could, hopefully, even though I kind of jump around sometimes, or try to give some of the intuition behind it, and then let you look at it tonight, and then hopefully maybe ask some questions tomorrow, especially if something isn't still clicking yet. But this is, like I said, this is only the general first step before going into a very, I don't want to say it's difficult. It's more about the fact that there's so many choices on how you present, how you talk about it. That's where the difficulty comes, because you have to find a way that it holds the interest of a bigger audience, in terms of the research itself. That's where it becomes a little bit difficult. You have to make sure that they understand the intuition, they understand why your choice of your point of evaluation is important. Okay?